All right, welcome back. This is 4.3. We are going to be looking at the stretches and the compressions of graphs of functions. So, last two lessons we talked about translation and we talked about reflection. Today we're going to talking about making the graph bigger, right? Stretching it or compressing it. Okay, so let's quickly review what we did last time, which was reflection here. So if the question says, what is the equation of the image of y equals x squared plus 2x minus 3 after a reflection in the y-axis? So remember, if there's a reflection in the y-axis, this means x is being replaced with negative x, right? Y-axis is the vertical one, so if we reflect over the vertical axis right there, the positive x becomes negative x, and the negative values of the x becomes positive. So the equation of the image graph is going to be y equals, now I see x, so I'm going to replace x with negative x plus 2 times, again, negative x minus 3. If you expand this, you should get x squared minus 2x minus 3. Okay, so that's what you have to do. You're simply replacing x with negative x if there's a reflection in the y-axis. All right, so now we're talking about we are going to talk about the stretches. Okay, so either expansion or compression of the graph. So last time or two lessons ago, we saw y equals what do we have? F of x minus c plus d. Recall c is about horizontal translations and d is about vertical translations. Today we're going to introduce two other variables. They are a and b, so it's in this form, y equals a times f of bx. Okay, and we'll combine these two together next lesson. But for today, we're going to look at a and b only, so we're not going to be looking at c and d. Okay, so now based on this, if we have x minus c here, we know that c is horizontal translation because it's with x. Similarly, b is horizontal expansion or compression because b is with x. A, just like d, really exists outside of the function, right? You see that's the function, plus d is at the end. Similarly, a is actually in the front, so this talk about the expansion or compression vertically, okay? So we're going to compare them. Now, let's look at A first, okay? Let's see how A affects the graph. So what we're going to do is we are going to use the green graph right here as our base graph. This is the square root of x squared, or sorry, the square root of x. This is the graph of square root of x. This is the base graph. We're going to compare every single graph with this graph right here in the middle. Okay, so let's look at A. When A equals to 4, what happens? Well, when A equals to 4, you can see that's this graph right here. This is when A equals to 4. When we try to compare something vertically, what we have to do is we're going to fix the x value. Okay, we are going to fix the x value. So you can see we're going to fix the x value at 1. Okay, so here is the x value of 1, and the y value when x is 1 is 4 for y equals to 4 times root x. And you can see for the orange graph, I don't really have an orange color here, so I'll use red still. Okay, so for this graph, but I'll do it with dash. For this graph, 2 times root x. So when x is 1, you can see if we go up, that's right here, the y value at when x equals to 1 is 2. Okay, the y value is actually 2. So notice how this and that is the same, this and that is the same. And it is because, now we're going to use the green one for the original graph. When x is 1, the y value when x is 1 is also 1. This is also 1. So notice how these 2 and 4 are just the multiples of the 1s. Okay, so let's see if that's true with the blue graph right there. Okay, so for the blue, when x is 1, the y value right here is at 0.5. And again, this is simply the factor times the original y value, right? That's 0.5, so that's 0.5 times 1, which gives you the 0.5. And you can see for the gray, or maybe black, I can't quite tell, doesn't matter. That's this one right here. And this, the y value is 0.25. And again, that matches with the a value right there. Okay, so for a, what happened is this. If a, the absolute value of a is greater than 0, sorry, not greater than 0, greater than 1, then, okay, so if you recall, this absolute value means we don't care about the sign as long as the number, right, that number itself could be positive or negative. But if that number, without looking at the sign, is bigger than 1, then we will have a vertical expansion. Okay, I will not write vertical expansion again, so I'll just say VE, okay, by a factor of A. Similarly, if the absolute value of A is between 0 and 1, so like 0.5, 0.25 in our case, then we will have, we'll have a vertical compression, okay, because it's compressed vertically, right? So you can see the graph is being either stretched vertically or compressed vertically, right? You pull it up or you push it down. So we will have a vertical compression, so VC, by a factor, I should say absolute value of A, by a factor of, again, absolute value of A. Okay, so what happened is the original coordinates of xy becomes x comma a times y, right? You basically just multiply the value of A to get your either expansion or compression. Okay, now, so that's for A. As for B, because we're looking at, or we're trying to compare what happens horizontally, so what we need to do is, instead of fixing the x value, we are going to fix the y value. So I'm going to fix the y value at 1 and see what happens. So when the y value is equal to 1, for the original graph, the green one, so I guess I need to use the green one. For the green one right here, the x value is at 1. Okay, let's see what happens when b is equal to 4. Okay, so when b equals to 4, again, same thing, I'm going to fix the y value at 1, and for the red graph, here is my new x value, and this is actually 0.25. Okay, and for the orange one, the value of b is 2, so now, again, I'm fixing the y value at 1 right here. The new x value is actually 0.5. Okay, so it kind of had an opposite effect as what happened to A. If the value of b is 4, it's actually a quarter. If the value of b is 2, it's only a half. So it looks like it's just the reciprocal as the factor. So I think we can assume if the value of b is 0.5, then the reciprocal of 0.5 is 2, right? We just double that. That's kind of the opposite. So I'm guessing our x value is going to be at 2 now. Okay, so let's check. So let's try that with blue here. When y value is 1, the blue graph has an x value of 2. Makes sense, right? That's exactly what we predicted. So I guess for the last one, the gray, because the value of b is 0.25, so the reciprocal of 0.25 is going to be 4. So I'm assuming it's going to be a 4 for the x value when y equals to 1. Let's see. So here we go. We move. Oh, indeed, it's going to be right here. Move down. That is definitely 4. Okay, so the factor is not just b, it's actually the reciprocal of b, which is 1 over b. Okay, so now here we go. For b, if the absolute value of b is greater than 1, then we will have a, in this case, again, because it's greater than 1, the reciprocal of something that's bigger than 1 is actually going to be a fraction. It's 1 over that number, so it's 0 point something. So this is actually a horizontal compression. We'll have a horizontal, horizontal compression. And again, I will not write this again, so I'll just write HC by a factor of absolute value of 1 over b. Again, b could be negative, but that just means there's a reflection as well. In other words, if the value of b, the absolute value of b is between 0 and 1, then we will have a horizontal expansion by a factor of, again, the absolute value of 1 over b. Okay, so the new x coordinates is not going to be x or bx, it's going to be 1 over b times x, which is x over b, comma y. Okay, so that's basically the summary of today's lesson. Now we're going to look at some examples now. Okay, so let me change the color here to red. Okay, so let's see here. Here are the coordinates, or here are the 4 points. Here's the graph. Negative 3 comma 2, b is negative 2 negative 1. We have d, we don't actually have c, 2 comma 0. E is 3 comma 3. And in this case, we can see if we compare with y equals a f times b of x, or sorry, a f bracket b of x, or f of bx. What am I talking about here? Y equals a f of bx. We do not have a value, or the value of a is simply just 1. However, we do have b as negative 3. That means we would have a horizontal compression. Again, because the value of b, if you don't look at the negative sign, is more than 1. Okay, so the factor will actually be 1 over negative 3. Okay, so that means it's being compressed horizontally, and it's also reflected over the y-axis. So we are going to change the x values now. All you need to do is simply multiply the original x value by negative 1 over 3. So negative 3 times negative 1 over 3 is positive 1. The y value remains the same. It was negative 2. If you multiply that by negative 1 over 3, that gives you positive 2 over 3. And the y value remains the same. If you keep going, this will be negative 2 over 3, comma 0. This will be negative 1, comma 3. So now we can plot these points. 1 and 2 is here. 2/3 and negative 1 somewhere here. Negative 2/3 and 0 will be somewhere here. Negative 1 and 3 is here. So here is new graph. Here's the image graph. Okay. The domain does change. Okay. Now the new domain actually goes from negative 1 to positive 1. However, because there's nothing, we didn't do anything with the vertical values or the y values, so range does not change at all. It still goes from negative 1 to positive 3. Okay, and that was the case for the original range as well. But you can see the original domain was not the same. It was from negative 3 to positive 3. Okay, so that's the example. Hopefully that was okay for you. Here's the question we need to think about first. Well, I guess I kind of tell you already. Does it matter if we do reflection first or stretches first? No, it does not, because both involves multiplication. You can multiply a first or b first. It doesn't matter. Okay, so no, it does not matter, because both are multiplications. Hopefully that gives you a preview of what's coming tomorrow. When you do translation and expansion compression, the order does matter because we have to do multiplication first. All right, here's the second example. Actually, yeah, sure, I'll do it. Okay, so I'm gonna label 3 points. So let me pick this one right here. That's my A, which is negative 2 comma 3. Here's my coordinates of B, 2 comma negative 1. I'll pick this one for C, 6 comma 3. Now here it says we have, again, we're comparing with y equals a f of bx. Now in this case, b is just simply 1, right? Because there's nothing in front of x. But in this case, a is equal to negative 0.5, which means we have a vertical expansion. Sorry, this will be a vertical compression because that's the value of a, so we just take the factor as it says. So this is a vertical compression by factor of negative 0.5, or really by 0.5, but then we also have a reflection over the x-axis. That's right. So in this case, because we're changing the y values, all the x values will remain the same, so we don't need to do anything with those. For the y values, you simply take the original y value and times the factor right there. So 3 times negative 0.5, negative 1.5. And you take negative 1 times negative 0.5 would be positive 0.5. 3 times negative 0.5 is negative 1.5. Now we have all the points. We can now plot. I guess I'm going to state the domain range first. So in this case, the domain would be actually all real numbers because it keeps on going forever. Showing arrows here. Range, in this case, y is greater than or equal to negative 1. Now I will use a different color. Okay, now let's plot these points. Negative 2 and negative 1.5 will be somewhere here. 2 comma 0.5 is here. 6 and negative 1.5 will be here. So the graph looks like this. Okay, you can see domain does not change because again we didn't do anything with the x value, and I mean if it's all real numbers, even if it's divided by 2 or times by 2, it's still going to be all real numbers anyways. However, range is going to change because we not only compress it, we also flip it, right? So now it's not greater than or equal to anymore because we had a minimum, but now it becomes a maximum. So the range actually becomes y is less than or equal to 0.5. Okay, so hopefully these two examples help you to understand what's happening here with the expansion and compression. There is the practice question for you to practice, to try. Okay, let's give it a try and we'll come back. All right, so this is what should have. We notice that the value of a is 2, the value of b is negative 0.5. Now that means the factor, vertical factor, is going to be simply just doubled. For horizontal factor, remember it's 1 over b, so it's going to be 1 divided by negative 0.5, which is negative 2. So really the factor is 2, but there's also a reflection over the y-axis. So we are just going to do it all at once. So this is really what's happening, right? X and y becomes negative 2x, comma 2y. So that's what we're going to do. We're just going to multiply every single x coordinate by negative 2 and every single y coordinate by 2. So this is going to be 8, 6, 2, negative 2, negative 6. For the y values, it's just going to be double, so negative 2, 2, 0, 4, and 4. Now we can plot. 8, negative 2 is here, 6 and 2 is here, 2, 0, and negative 2 and 4, and then negative 6 and 4. So there's my new image graph. All right. Hopefully that's all you got. Okay, not too bad for you. We'll move on, and we'll continue with this example right here. It says the graph of y equals to f of x, which is equal to x cubed minus 2x squared minus 5x plus 6 is shown. So here's the graph of f of x. We want to write an equation for this y equals 1/2 f of 2x, and then sketch it. Okay, so I'll do this first. Okay, so what this is telling us is we basically just apply what it says here. Here we have the 1/2, and it says put 1/2 in front of the entire function f. So this is the entire function of f of x. So we are going to put 1/2 in front of this entire function. And this 2x is telling us we need to replace x with 2x. So every time I see x, like x cubed right there, I need to put 2x instead. Okay, so I need to put 2x instead of just x cubed, minus 2 times, now I see x, again I'm going to put 2x instead, minus 5, I see x, so I'm going to put 2x instead, plus 6 at the end, and then close the bracket. Now we just need to expand, that's 1/2, This is going to be 8x cubed minus 8x squared minus 10x plus 6 times everything by half. You should get 4x cubed minus 4x squared minus 5x plus 3. So this would be the image graph. This will be the equation of the image graph. Okay, now we can actually sketch this, okay? So I'm gonna pick, again, some points from the graph right here. I'm gonna pick this one right here. That's my A, -2, 0. I'll pick that one. Okay, this is just gonna be an approximation, okay? It's not exactly that. I'll make things a little bit easier. Let's say this is -0.75, comma 8. Okay, again, it definitely is not, but I'm just gonna say that's what it is. This is 1, 0. We definitely need this point here. I'm just gonna do an approximation. This is a little bit off, but I'm not too worried about it. And we have E, that's 3, 0. Okay, so these will change. Okay, so our x, y will then become something else. Okay, because we have 1/2 in the front, so now we know the y value becomes 1/2 y. The x value, the value of b is 2, and remember, if b is 2, that means factor is 1 over b, so it's going to be 1 over 2, so this is going to be 1/2 x. Okay, so basically we're just going to divide everything by 2 for both x and y. So now let's do that. So that's going to be -1, this is -0.375, that's 0.5, that's 1, that's 1.5. For the y values, do the same thing, divided by 2. So 0 divided by 2 is still 0. That's a 4, that's a 0, -2, and 0. So those are our new coordinates. We can just plot them now. -1, 0 is, so I'm gonna erase, I'm gonna use a different color now. Otherwise I have too many red dots. I'll confuse myself. I'll use blue now. Okay, I'll use blue for these. -1, 0 is here. -0.375 and 4 will be somewhere here, I guess. It's 0.5, so somewhere here. 0.5 and 0. So it looks like this. And then 1, -2. And then 1.50. So there is our graph. Okay, something like that. Okay, so really to do any of these questions, what you need to do is to identify the values of A, B, C, and D's, and then just use the knowledge of how they will affect the graph or your coordinates, and then just act accordingly, then you'll be able to get your image graph. Okay, now we're going to take a step back and we're going to do something different here. We are actually going to do the opposite. Okay, so we are going to take what we have on the graph and then we want to figure out what actually happened. So here it says the thick curve is a transform graph of the thin curve f of x. Determine the transform function in terms of f of x. So like I showed you earlier, we are going to be looking at y equals a f of bx compared to y equals to f of x. So what that means is we need to figure out what happened vertically and horizontally, so then we can figure out the value of a and b. So I am going to write this out right here. The coordinates a is -3, 0, b is 1, 0, and this we have a c here as well, -1, -4, and a becomes d, which is then -6, 0, b becomes e, which is 2, 0, and f is -2, 16. So what we need to do is this. We need to use the fact that x, y will become, again, based on a and b, it's going to become x over b, ay. Okay, so that's what we got earlier in the lesson, right? All the way back to the first page. Here's my ay, and there's my x over b right there. Okay, so we have to use this as the fact. This is the original x value. This then is the new x value. Okay, so that means we have the old x value divided by b will give us the new x value of -6, right? This goes to -6. Okay, well that's not too bad. I mean, I think we can figure it out. From here, we can simply solve for b, I guess. We can cross multiply, put it over 1. So we have -3 times 1, which is -3, equals -6 times b. To solve for b, divide both sides by 1/2, or -6, you get 1/2. There's the value of b. And you can do something similar for value of a. Now, we need to do it with the y values though. Now, because that goes from 0 to 0, that's not really going to tell us much. That also goes from 0 to 0, that's not going to tell us much. So we have to use these two, 4 and 16. So the original y value, if you multiply by y, right, 4 or times by a, that should give you the new y value of, what is it, 16, right? The original times by the value of a gives you the new y value. So then divide both sides by 4, you get a equals to 4. And there you go. So the factor or the equation of the image graph is going to be 4 f of bx, which is 1/2. Okay, so this would be the equation. Next lesson we'll deal with translations as well. So it's going to be it will be more tricky, okay, in the next lesson. But for now, I think that's good. We just need to try something simpler first, I suppose. Okay, here's the last example, which is actually could be difficult. Okay, let's see. It says, what is the horizontal transformation? Okay, so this is key. It tells us it's horizontal transformation already. That is applied to the graph of y equals 14 minus 3/5 x squared to obtain the graph of y equals 14 minus 4 out of 15 x squared. So it already tells us it's horizontal transformation. And there is no translation at all. And how do I know? Well, because if there's a translation, that means x has to be replaced with x minus c, which is a constant. And if you do that, let's say square, right? Let's say x minus 1 squared. You actually get an x term, but there is no x term here, right? So we know there's no translation here at all. We just have either expansion or compression. So what's happening then is, if we apply the transformation, which means we need to replace x with x over b, right, because that's the factor, this will equal to 14 minus 4 out of 15 x squared, right? This is the transformation that we applied to the original function, and it gives us the new function right there. Okay, so that's what we have to do. Now we just need to solve for b. Because both sides have 14, and they will just cancel, right? 14 and 14 right there will cancel. That's a negative sign. That's also a negative sign. They will just cancel as well. I mean, really, if you minus 14 minus 14, that's why it cancels. Both become 0. Multiply both sides by -1, so the negative sign will become positive sign. Okay, so now I'm going to expand this. I really have 3 over 5 times x squared divided by b squared. This is going to equal to 14 over 15 x squared. Okay, now if I kind of rearrange this, I have 3 over 5b squared times x squared is equal to 4 over 15 x squared. Notice how both are multiplied by x squared, so that really just cancels out as well. So now our final equation is going to be 3 over 5b squared is equal to 4 out of 15. Now we can solve for this. Again, you can cross multiply. 3 times 15 is 45. 4 times 5 is 20. And then b squared is still b squared. We can then divide both sides by 20. So you got 45 out of 20 is equal to b squared. We can reduce this by dividing both sides, or top and bottom, by 5. You get 9 out of 4 is b squared. Now you can square root both sides. Remember, when we square root this, you end up with positive negative answer. Then square root of 9 over 4 is simply 3 over 2. Okay? So that's it. The value of b is either positive 3 over 2 or negative 3 over 2. So what is the horizontal transformation? Well, there is two possibilities. Either horizontal expansion by a factor of, oops, I cannot spell factor, by a factor of 3 over 2, and reflection in the y-axis. So that's one possibility. The other possibility is just horizontal expansion by a factor of 3/2. A factor of 3/2. So this is the case where b is negative 3/2. And this is the case where b is just positive 3/2. So there's no reflection at all. Okay, so that's what you can do to solve this question. And this one really is actually quite challenging. Yeah. Case. Okay, so that is it for this lesson. If you have any questions, please do let me know and I'll help you. Otherwise, good luck with your questions.